Welcome to the presentation about .NET interoperability for beginners. I assume we don't have too many beginners here because this is not really a beginners conference. What I'm going to do here is talk a little bit about basic stuff for .NET interoperability in Microsoft Dynamics NAV. My name is Vjekoslav Babić. I'm an MVP. I've been writing a blog. Maybe you have read a little bit about .NET Interop. I've blogged quite a lot about it. And this is my third time here on this conference. And when Luke asked me to deliver something this year, I actually submitted an idea to talk about advanced stuff in .NET Interop. And then Luke asked me, can I also do something for beginners? And I said yes, and then I realized I had a little trouble, because 2 years ago I also delivered .NET Interop class here, which was more or less beginning or introductory class for .NET. So I wanted to make this one a little bit different. So we're going to see what kind of differences I planned when we get to the agenda slide. Let me start by just giving a couple of visual examples. This is how users see programmers, right? We are some kind of aliens typing off at keyboards, and nobody understands what that is. And this is how we see users. And now, yeah, okay. So now, when we are actually coding in CAL, this is how we feel. This is like we are really in control of everything. But when it comes to .NET, I believe most of us feel something like that, trying and poking and everything and trying to make it work, and we don't know why it does not work. So what I'm going to try to do in this class today is to simply change that a little bit. And before we go on, just one question for you. What do programmers do for a lot of time? Can anybody tell me? Okay, the folks, is there anybody who was attending my pre-conf class yesterday? Nobody? Okay, then you listen to me, or actually they listened to me. I said nobody should come today. If there is somebody, please keep quiet. So, what do we do, the programmers? We think a lot. Okay, what else do we do? We convert coffee to code. That's a good one. I have to remember that. Something else that we do? Debug, good. There is one more thing that we do, but before I re-ask the same question, let me show you something. So we all know what this object is, right? It's a wheel. It's our friend, and it helps us come from point A to point B. It drives our cars, powers electricity, whatever. So a question for you. What do we do a lot of time? We reinvent the wheel. That's true. We do reinvent the wheel. So especially we reinvent the wheel with simple things, like the things that should kind of work by themselves, so we just simply come again with new ideas and new stuff for something that already exists. And the problem is not like reinventing the wheel. It's okay. There are pretty good wheels today compared to the wheel on the previous picture. The biggest problem is if we try to reinvent a wrong wheel, and then we make a bad solution for something that should easily work in the correct way. So, what are we going to do today is something a little bit different than what we did 2 years ago when I introduced .NET Interop. So, if you read the agenda for this presentation in your conference guides, you could see that I was talking about concepts such as constructors, methods such as generics, such as, I don't know, this or that. So, I'm not going to really give some dry theory. What I'm going to do is try to give you live examples for most of the wheels that we tend to reinvent. And I mean, the biggest problem with CL is not that we are reinventing wheels. The biggest problem is that CL itself does not give us much space to do different. So we actually have to do things in CL which have already been done in other languages. So what I'm going to do here is on these 4 groups of topics. I hope you can read them. It's a big screen. I'm going to try to give you a couple of very practical examples of how you can use .NET to help you work with, or actually help you solve common everyday problems. So we are going to talk about managing strings and managing texts. We're going to talk about how to manage dates, times, numbers. We're going to talk about how to access the operating system, the file system, the environment, and in the end, how to manage data through arrays, collections, and streams. So what we are going to do is pure CAL. So there will be no Visual Studio, and I like to call it CAL.NET. So we are actually going to use only .NET, or there'll be an occasional variable which is like an integer or something else, which is CAL variable, but most of this, what we're going to do is going to be .NET. So now that I've mentioned .NET, I assume that you all know that there is one variable type which has been with us since version 2009 R2, which is called .NET. So when you declare a variable of .NET type, it actually gives you access to the whole .NET world that is available for us to consume. When you declare a .NET variable, there are two things that you must specify on that variable. First, you must specify the assembly, and then you must specify the type. So what is the assembly and what is the type? Assemblies are collections of functionality which are compiled into shareable, executable files, typically DLLs, but they also can be exe files. We typically reuse DLLs. So DLLs are nothing but collection of types. The types are basically similar to what we know as code units. So if you are unfamiliar with .NET and with how object-oriented development works in .NET, then a type is closest to what we call a code unit in CAL. So type actually includes functionality. There are many different types of types. The most common ones that we use are classes and interfaces. Classes are actually what we would call code units. They really contain the code, they contain the functions that we can call. We just call them differently in .NET. And interfaces are just blueprints for classes. They explain what a class must do, but it doesn't define exactly how the class does it. So to learn more about interfaces, you can join me tomorrow in the Black Belt session here. And today I'm going to mostly talk just about classes. There will be just a couple of mentions of interfaces where I will explain how and why we use them. Each .NET variable that we declare has 4 groups of functionality available to us. The first is methods, then we have properties, then we have constructors, and we have enumerations. So we're going to talk about all of these. So I'm not going to spend too much time talking. I'm just going to go straight ahead into the first class that I'm going to present. And you might ask yourself, why do we need to talk about strings? I hope I explain. So let me see. Who has ever had to do something with managing text, like concatenating, deleting, analyzing content, etc., etc.? So I would assume that it would be just about everybody. So there were a few hands down, so either people were not really never needed to do something like that, or they just were shy to put the hand up, or it was, it's just after lunch, so who wants to put hands up every 3 minutes and so. So let's talk about string. String in .NET is much different from text in CAL, even though they achieve the same thing. Traditionally, we had a text variable in CAL which could handle up to 1024 bytes or characters, and that was about it. So we couldn't actually declare or make a string bigger than that. We did have one data type which was called big text, but it wasn't really useful for most of the situations because you couldn't really manipulate easily with the contents of the text. It was useful in some scenarios, but for most situations, it was just useless. So in .NET, system.string can hold up to 2 gigabytes of data, which is pretty much. And nice thing with system.string is that it fully maps to the text type in CAL. So if you have a text variable in CAL, it actually is deep down in itself, it is system.string. I assume that you know that ever since 2009, at least on the service tier, and now in 2013 everywhere, all code executes really as .NET. So nothing executes as some kind of CAL compiled into something obscure. It is really first translated and then compiled. And it is fully running on .NET platform, which means that any data type in NAV must map to something in .NET. So text variables map to string. And this mapping is done pretty nicely. So instead of using text variable, you might just want to use string variable. So let me show how to do that. So I will start with a new code unit. And just one hint at the beginning. I will not just be showing prepared demos. I'm going to really type in front of you to show how easy it is. So none of this is really rocket science. It's really simple concepts. And for some demos, I have prepared stuff just because of the time constraints. Okay. So here I will start by declaring one text variable. Sorry, not text variable, string variable. I'll just call it string. And oh, I have problems with my keyboard. It's happening sometimes, and obviously it's happening now. It's Windows 8.1 drivers. I don't know if you have heard of that issue. Okay, I will do my best to try to do it without a keyboard. So I'm trying to select .NET, and then I'm going to choose the subtype. So the subtype is defining what this .NET is. So it is first the assembly, which is the library which contains the functionality, and then we have to choose the type. For most of the time today, and for most of the time for you as well in practice, you will use one very, very common assembly in .NET. Does anybody know which one that is? Yep. System. Yes, we will use system, but there is even a more common one. MS-corelib, that's true. So what I'm going to do is reference the MS-corelib. So here we have two tabs. One is Dynamics NAV. This is the list of the assemblies deployed directly into my installation of NAV, actually, for the development environment. And .NET is the global assembly cache. I will not talk much about global assembly cache today. We might discuss it a little bit tomorrow. So here I will select MS-corelib, and then I will select the type called system.string. There is no simpler way. People ask me, like, is there a simpler way? Unfortunately, not really. So now I have this system.string. Let's take a look at the difference between system.string and a text variable. So if we look at the symbol menu for text variable, there is nothing, as you can see, that the text can do. So whatever you want to do with the text variable, you have to call the system functions, which are kind of limited when compared to .NET. So in .NET, in the string class, you have plenty of methods and also properties that you can use to manage strings, like concatenating them in a smart ways, like splitting them, like doing replaces, searching at the beginning, at the end, etc., etc. We're going to see plenty of different things today, what we can do with the string. There is one simple thing that I'm just going to show you, one small tip. Frequently, when managing text, we are typically like importing data or preparing data, similar. So very typical situation that happens in most of code that handles text on large scales, we will have something like this. If t is empty, then do something, right? Who has ever written something like that? Okay, I did expect people to raise their hands. Is this bulletproof? It's nothing proof, so why not? How many, like, can you imagine a failure point of this line? It tests for an empty string, right? But there are plenty of different ways how a string can really be empty, especially in .NET world. So now that we have .NET integrating with NAV, string can be empty, it can be null, it can contain like blank spaces. So maybe you wanted to make it smarter, so you did something like this, like instead of just checking if t is blank, you could say, well, I also want to ignore any white spaces, so you could do something if del. Okay, now d worked a couple of minutes ago. If del chrt, and then this, and then this. So you make it smarter, like, okay, I'm going to trim any spaces from the beginning and at the end. Is this bulletproof? Who thinks it is? Okay, no, so everybody agrees with me. Actually, to help with all of those situations, when you need to handle not just null strings, not just strings which have something at the beginning or the end, also the strings which might have carriage return characters, which is pretty frequently with the importing text files. And similar, .NET can actually just help you with a simple function, so I could say if string, and then is null or white space, and then I just specify which one. And that's it. So this is just one of the examples of how you can use string class in .NET to help you making a smart move. So actually doing multiple tests at once. So here, this is a typical situation. So a typical bug that most of developers do, and it's very difficult to test in the practice, is checking just for blank string. And here, there is a simple function which can do that. So again, this is nothing too smart. This is just a very, very simple function that can handle this specific situation. I'm not going to talk about string all day, so I'm moving to the next one. I'm going to the string builder. So there were plenty of people who just said, yes, we did do stuff with text. Now, who had to handle large amounts of texts? Like really, like big files? Okay. So did you ever have to create large amounts of texts for some kind of export? Yes, I see people nodding. So is there a problem of making a code which, for example, looks like this? So let me just type some quick pseudocode and then ask you something. So if I do for something is, and then some large number, okay. Who has never done that? Something similar. Okay, who has ever done that? Okay, good. Is there a problem with this? Oh yeah, which one is it? It's slow. And why is it slow? Because of the way how variables work in memory. So things like that. I mean, if you do it once, it's okay. If you have a small piece of code which is not really relevant, it's okay. But if you are generating long texts on the go, and you do it repeatedly, let's say in some kind of web services call or in some kind of frequently run routines, this is a killer for performance, because every time you concatenate, it basically has to take the string, copy it in another place, append something, and then copy it back. Then next iteration, copy it, append, copy it back. So each copy operation loses time. Append operation, of course, it has to lose time, but there are two copies involved in each concatenation. And each copy is progressively slower the longer the string is. So this is a very bad way to manage long strings. So again, I'm going to give you a simple class which can handle really quickly long strings. So here I'm actually going to turn this pseudocode into a real code. So I'm going to declare a variable called I. It's going to be an integer. And then I'm going to increase this I by 10 characters in every iteration. Let me not do 100,000. Let me start with simply 10,000 iterations. And then let's do message, I'm done with characters. And then str of t. I will save this. And I will run that. So I've put this ready so we can see how much time it takes to process this. So I click yes, and then I wait. Okay, it was some time, okay? So if I increase it by, like, let's say, 5 times, it will be 5 times slower. Let's keep it like that. Let me not run that. So I said string builder is a class which can help us handle large amounts of text. And it is really optimized for that. So instead of just writing this t equals t plus something, I'm just going to declare another variable. Is going to be called string builder. And then I'm going to specify the class, the assembly first, and then system.text.stringbuilder. it's there. Okay, so I'm going to make an intentional bug at the beginning, just to make it simpler for you to follow. Again, 50,000 iterations, and then the same thing in the end. Just not strlen, is going to be string builder length. Oh, right. Length. Then I did make a typo. Length. Okay, that's it. So this compiles, but it doesn't run. Let me explain why it does not run. There is one concept which I forgot, not really forgot, I intentionally didn't introduce it yet, which we must do with string builder or many other types in .NET. With strings, initially, when I use my string variable, I could do anything with that just by declaring it, or at least I could do most of things just by declaring a string. With most of the classes in .NET, we actually have to call a constructor. So there is one thing that I must do with my string builder before I can use it. So I will go back to my code, and before using my string builder, I will put here string builder is string builder dot string builder. And let me run this now, and then I'm going back to the theory about constructors. So I'm ready, then I click yes, and then I wait, and a little more, and a little more. So now my string is getting progressively slower, so it's not 5 times as slow as I said it would be. It is more and more and more slow. And let's actually wait for it. I'm going to go back to my slide while this string is struggling under 50,000 iterations and explain what constructors do. Constructors are methods which instantiate an object. So a class is a blueprint. It defines what an object can do. But in .NET, we cannot just declare a variable as we can in CAL. In CAL, when we have a code unit or when we have a record, we just say like a code unit 12, that's our variable, and then we start calling it immediately. In .NET, we cannot do that. In .NET, we first have to create an object. So the constructor is a method which does that for us. So we get an instance of an object. So every object has a blueprint, it defines what an object does, but then each instance of the object is a separate, it has separate place in memory, it runs completely separately, and we can handle multiple objects of the same class. And for the system to be able to differentiate between those, we actually must call constructors. Constructors are not just used for creating an instance, it's the typical thing they do. They are also there to help us initialize, like we can set properties to their default values. We can verify certain conditions whether we want stuff to be constructed or not. So it's the most important thing before you can start using a variable. With constructors, at least for CAL folks, they are nothing special. They resemble a little bit the create function that we are used to use with automation, or actually we did until it was actually obsoleted in 2013, at least as far as server code goes. Constructors are slightly different. So we don't have the create function, we have to call a specific syntax. And this syntax might look a little bit confusing. So here what I have is this string builder equals string builder dot string builder. So why do I have all of those string builders in that line of code? So the syntax is actually simple. The first part is the variable. We are assigning the instance to the variable. So our variable of type string builder will receive the instance of that string builder. So we simply say variable equals something. And then to call the constructor, we have to reference a method. So how do we reference methods in CAL? Naturally, we just define the object and then dot and then the name of the method. So if our string builder was called S instead of string builder, we would have said S equals S dot and then the name of the method. And all of the constructors are always called exactly as the method is called, as the class is called. So since the class is called string builder, the constructor is also called string builder. So let's take a look at here. Okay, it's done with 50,000 characters, actually 500,000 characters. Let's take a look at string builder. So now it asks me, am I ready? I'll say yes, and it's done. So that's amount of time that it takes for a string builder to process the same. I think this must have been convincing, at least that you would not use strings anymore to handle large pieces of data. Now, one thing that you could have noticed when I was showing methods that either string or any other object can do, you might have noticed that there are multiple instances of the same one, like compare, and then compare, 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 compare. And then I have like concat, and then concat, concat, concat. So this is a typical concept in .NET, which is overloading. In .NET, much different to CAL, the identifier of a function, or a method, or a member of a class is not just the name. Okay? So every function of a class has a name, but the name can be repeated multiple times. Apart from the name, identifier of a function, or actually a method in .NET, is the signature. The signature is name plus all of the parameters and their types. Okay? So together with the name and all of the parameters, we have one unique method. So we cannot have twice definition of exactly the same signature, but we can have multiple signatures with the same method name. This is overloading. So literally, .NET perceives them as different methods. They are not a single method. They are different methods. It's just that .NET allows us to do that, and CAL does not. So it might be a little bit confusing when using it for the first time, but you quickly get used to it. You simply have to specify which method you want to call. So for example, here, for my string builder, I was calling the append method, and obviously there are like 20 of them. So each of them has different set of parameters, and you can actually see down there, I don't know if I have any kind of laser. So the signature is shown down there. So you select like any one of those, and it shows you different signatures. So every time it's a different parameter type or different number of parameters. So here, for example, we have 3 parameters with different types. So these are overloads. When using the symbol menu, you do not need to worry about which one you select, because when you click append, it simply takes the append name, and then it's the job of the compiler to determine which one you are actually using. So by specifying correct parameter types, you are actually saying to the compiler which method will be called. So this is typical concept in .NET. So you'll frequently see that. So you must be sure to simply specify the correct number of arguments. So the best thing to do is just to simply use the symbol menu, then try to find the method signature you're looking for, and then just remember what are the types, and then pass those types on, and the append method will work. Or actually any method will work exactly as you wanted it. Now that we have seen how string builder is fast, it really is fast, it can handle large amounts of text in really no time. Let's try to measure how exactly fast it is. So another thing that a lot of developers do in a funny way. So who has ever had to measure time for anything in NAV? Okay. So it might have been for performance testing, it might have been just for whatever purpose, like you wanted to say to users, like, this is how much time has passed in this and that moment. So how did you do that? Or actually, let me guess, you had 1 or maybe 2 datetime variables, right? And then you had maybe a third one, which was duration, and then you basically subtracted one from the other, right? What if you wanted to, like, calculate some functionality, how much it takes, and it was in a loop? And you were not interested in how much overhead the loop adds, but how much exactly it takes to, for example, post something. And the loop might have added overhead. Then you would have to introduce some more complicated mathematics there. I mean, it's still second grade mathematics plus and minus, but plenty more variables and a lot of more stuff. So in .NET, we don't have to do that. We have the system diagnostic stopwatch class. So let's take a look at how this class actually helps us measure time that is spent on an operation. So I will declare a stopwatch. So I will just use SW, and I'm going to system. Now this is not MS core lib, so it's system, and then I'm going to select system.diagnostics.stopwatch. And of course, I first have to instantiate the stopwatch, so I will say stopwatch is stopwatch.stopwatch. It's actually with lowercase w. .NET is fully case sensitive, and CL also has to be case sensitive, because again, this might be a different method. So that's why you must make sure that you type it correctly. What I'm going to do is I'm not going to measure the time for the whole loop, because I'm not interested in any overhead that 4 might add. It would be very little, but still it would add some overhead. So what I will do is measure just how much time it takes to do this operation. So I just say stopwatch.start, and here I stopwatch.stop. Let me reduce it to 25,000 because it's going to be much more manageable. Then, and this one as well, just for comparison purposes. And I'm going to add in number milliseconds. So let's take a look what this stopwatch can do for us. So stopwatch has start method, which starts measuring time. It has stop method, which stops measuring time. But if we start after stopping, it resumes. So just like any other stopwatch. And we can reset, we can restart, etc. And also it tells us how much time has elapsed. So this is time span. This actually maps to duration in NAV. Actually, duration in NAV is time span. Then we can see how many milliseconds have elapsed and how many ticks have elapsed. So it's not that we would ever need to practically use it, but stopwatch can also measure down to 100 nanosecond precision, unlike NAV, which can measure to 1 millisecond precision. So here I will just put stopwatch.elapsed milliseconds. Okay, so that's the first one, and here I'm actually going to just copy that part and put it here and in milliseconds. So again, I add the stopwatch here and stopwatch stop and stopwatch, sorry, it's SW reset. And that's it. So I will run this piece of code now. It asks me if I'm ready. Yes. Let's wait. So it's taking a little bit. Still a little bit. And it says that it has needed like close to 10 seconds to process this. And now with the string builder, it's actually 165. So this is this was about how to measure time. So frequently when you want to measure times for something, typical mistake that people do, especially in NAV, is to measure everything. Like you put the timer at the beginning, timer at the end. It doesn't give you a clear picture. And then if you want to get any more precise than that, it just causes too much problems in how to program that. Here with a stopwatch and maybe with a single instance code unit, you could quickly measure whatever you wanted and have like some kind of profiling embedded into your application on the places where you want. Stopwatch is not really slowing down anything, so it's kind of very useful class whenever you're interested in time measurement. Let's take a look at more theory and then more classes. When I asked the question, which assembly I'm going to use, somebody has said system. And it's, yes, we are mostly using stuff from system, but not from the system assembly, but from the system namespace. Namespaces are units which are helping us organize code in .NET. So we don't have anything similar in NAV. Namespace just has a name attached to a series of functionality. And then we can add more functionality to namespaces as we go. If we forget to add, let's say, a class to a namespace, it's not a problem. We can add it later to another assembly. Because one namespace can consist of multiple classes. Sorry, one assembly can consist of multiple namespaces. And one namespace may span multiple classes. So it's a many-to-many relationship. And this many-to-many relationship exists also in .NET. So if you take a look at the libraries which are part of .NET installation, you will see that you have this system namespace present in many different assemblies. And sometimes it's going to be difficult for you to locate the correct assembly. So, for example, if you want to locate this stopwatch class, you might not be sure in which exactly assembly it resides, because it may be in system.diagnostics.dll, it can be in system.dll, it could be in some other DLL, it could be in mscorelib DLL, it could be in system.core DLL, whichever. And you might not be sure. So with .NET, you have to frequently use documentation, either online or on your computer. So I'm going to show how to actually how to get information about the types. So here I will start by simply typing system.stringbuilder C#. And then I will land on an MSDN page which tells me everything about this class, including where to look for in CAL. So here it says that it's assembly mscorelib. So I go and look up mscorelib. And then I know that when I select mscorelib, I just need to look for this class. And string builder, this is the class name. System.text is actually the namespace name. So this system.text may exist in multiple assemblies. And also, people frequently ask me, like, how do we know where to look for? Like, how do we know what kinds of classes we have? So again, I don't have a silver bullet answer to that, but a good starting point is like starting from a problem. So you will have a problem that you want to solve, and then you could reasonably imagine that you're not the first person ever to encounter that problem. And then just use search engine, which helps you. I'm not going to say which one, it would be politically incorrect, but we all know which one to use, right, don't we? It starts with B, G, no, I'm not quite sure. Actually, there is one website which I can recommend. It's called stackoverflow.com. It contains a lot of knowledge about C#, .NET, so you just put C# and a question, like how do I measure time? And then you get the answer, and it will tell you like which one to use. And you will have practical issues with that, etc., etc. So let's move on. Another typical thing that we do with text, we are not just concatenating. Like if we only needed to concatenate text, string builder would be good enough. But there are situations when we want to do other things with text. Is there anybody who has not heard of regular expressions? Don't be shy. Okay, so everybody knows what regular expressions are, right? I can assume so. Okay, good. So what are regular expressions? They are used to match patterns in the text, to find stuff in text without having to like read all of the text. So if we want to search for a specific text pattern, we could specify that pattern and then literally make a query, a regular expression query on a large chunk of text. Who has here in this room done something with regular expressions? Okay, now keep the hands up, or just keep them up. Who has done that in NAV? Okay, so not many of you. Why? What's the reason for that? For all of you who put the hands down, probably because NAV doesn't handle regular expressions. And to handle regular expressions, you had to rely on some third-party utilities. .NET is a very comprehensive environment, so it has full support for regular expressions. So there is the system.text.regularExpressions namespace, which includes quite a lot of functionality to help you with matching text. So here I have a prepared example, just to save a little bit on time. I'm actually cheating because I've prepared the example yesterday when we had this class, .NET class for beginners. Most of the examples I will show today, actually I have written them yesterday together with the class. So I'm going to use a similar one. So here I have, just a second. So I have this isValidEmail function, which doesn't look too readable, but what it does, it verifies if I'm actually entering a correct email address. This is a regular expression. Don't worry if you don't understand it. Nobody does. So whoever tells you they understand regular expressions, they're lying to you. So you can write regular expressions, but you cannot read them. So that's kind of a unidirectional street. So this regular expression is actually specifying the content of an email address. So it's checking if an email address is valid. So if you want to validate an email address, what you could do is simply call this isValidEmail function. How does it work? Actually, this is a little bit hackerish here. I'm going to explain this function, how exactly it works. So I'm going to just take it apart into 3 parts. So here I receive a parameter which is called email. That's a supposed alleged email address. Then here what I have is, can anybody tell me what this is? You should know by now. This is a constructor, exactly. So I'm calling a constructor. What does a constructor do? It returns an instance, okay? So the result of this regex.regex is going to be an object of type regex. And I don't need that object in any variable, so I can just leave it like that. This is a nice thing in .NET, you can do that. And then, what can this regex object do? There is a function in regex object which is called match. This match function is taking the regular expression that I used to construct my object, and then it takes a string which I want to match with this regular expression. So this match will return a match object. The match object tells me a lot of things about the match. It tells me if the match exists, and if it does, at which position, how long it is, etc., etc. Plenty of things about the piece of text that I found in another text. And then this match also has a Boolean variable which is called success. Success is true if match was found. Success is false if match is not found. And then nice thing with .NET is that you really do not need all those variables. You don't need a variable of type, literally in C# you wouldn't even need a variable of type regular expression. You could just directly construct it from a class, not needing a single variable. So here I did have to declare at least one variable which was regex, because otherwise I wouldn't be able to call this functionality. But then I have constructed an instance, so this creates an instance. On that instance I call a method, and on that method I actually check a property, and then I return that property out. So this is something very easy, nice in .NET, that you can always just add more and more and more to end. So the compiler always checks what is the result of the previous one, and then you add dot, and then call members of whatever type it returned. So here I have a very simple one-line check comparison if this is a valid email address. Without this line, it could have been like 100 lines algorithm, which would still probably be a little bit buggy. So let's take a look at how it actually works. I'm going to customize my page 21. And then in the email field, actually not page 21, my table 18. And then I'm going to look for field email, and then here I'm going to add the validation. So tech days, it's code unit. And it's 74008. No, it's not. No, I'm not sure which number that was. So it's this one, 009. Okay. So here I will do if not techdays.is valid email. Don't hate me for hard coding the text constant. Not. Okay. And we can verify if it works. So I go to my customer card. Take this customer and then try to enter an invalid email address, such as this. It tells me this is not a valid email address. Maybe this.com is not a valid email address, but something at this.com is a valid email address. So that's how regular expressions work. What I'm not going to do here is like give you a comprehensive guide of regular expressions. I'm just trying to hint you in the direction that whenever you need to match any kind of thing within a text, and especially if it's a large piece of text, do not write any of loops or any algorithms. Regular expressions are the way to go for it, and .NET fully supports them in an easy-to-use way. The next type that we are going to introduce is the datetime type. I'm introducing it because for most of the things that we do, we are handling financial data in our databases. And this financial data always has at least one attribute, or actually at least two attributes. One is the date, and the second is amount. Date is very important, so we do handle dates. We do plenty of date calculations. So system.date, system.datetime, it fully maps to datetime data type in NAV, but it provides us with much more functionality. So let's take a look at what system.datetime can actually do. So I will go to my, sorry, not this one, but this code unit. I will create a new function. Or actually, let me create a new code unit. Save it as 50,004 datetime demo, and I will create a variable which I will call just dt. And here I'm again selecting from mscorelib assembly, and I'm using system.datetime. So if we need to calculate date or time in NAV, we typically use date formulas. So it's how NAV does that, so how CAL actually does that. So if we want to add 7 days to a certain date, we can use date time. We can use the date formula data type. The date time data type actually gives us a lot of information about the date itself. Like, for example, we can take a look at properties. So here we can see like specific parts of the date, so we don't have to use those functions like date part and then thinking like which part is which, is it 3 a year or is 3 a day, etc. So we have it directly as a member of datetime variable, or we can directly do calculations like add days, hours, milliseconds, minutes, etc. There are several limitations of date formulas. One of them, or the biggest one of them, is that date formulas cannot handle really nicely the time. Here you can also handle time calculations, and again you can do it down to precision of 100 nanoseconds if you need it for whatever reason. Like, I'm not sure if you are going to measure anything in nanoseconds, but still. So here you have really a plenty of methods which can help you calculate and analyze stuff about dates. I'm just going to show a very simple one which might be complicated to do with pure CAL. So let's take a look at DT. So I'm going to have DT is, and then I'm going to use constructor. I could use NAV code, but I just want to show how constructors work with overloads. So here I have year, month, and day. So what I'm going to select is year will be 2000, month will be February, and day will be 28. And then I will do message is leap year, and then DT is leap year. Just a second. I think I have to specify which year it is. So it is dt.year. Okay. So if I run that, I will see if year 2000 was a leap year. So it will say that it was a leap year. Okay. If I try another year, like 2001, it will say no. There are plenty of situations when, especially with datetime calculations, you might want to know if a year is a leap year or not. Here with the datetime class, you directly have access to that information. Okay, so that's another very interesting class that you can use. Now that I'm at the datetime class, let me show some other things that you can do with datetimes. So here what I could do is I could have the CAL datetime, and it's just going to be datetime. So what I can do is say that DT is CAL datetime. Or I could say that DT, which is my .NET, is current date time. Okay? So you can fully assign values between datetime in .NET and datetime in NAV. So they're fully compatible, assignment compatible. I'm going to talk a little bit about assignment compatibility of types a little bit later. Let's move on to next topic, which comes natural when talking about dates and times. So there are several things which we do with dates and times. Sometimes we print them on documents. Whoever prints dates and times on documents? Okay, I imagine it would be all of you. Still, same people are not raising hands, which means like, is everybody awake? Yeah. Okay, so when printing dates and times, did you ever have to print the dates in a language, like the name of a month or the name of a day? Okay, how did you handle that? Let me guess. You had, if you were smart, you made a code unit which did it for all of your projects, and then this code unit had a function which was called month name, and then you say like which number, and then it gives you February, January, whichever, right? No? A better way? Okay, so we don't have to think of that in .NET, because we have system.globalization namespace, which contains a lot of functions which allow us to manage culture-related information. When we say culture, in Windows terms, culture is not just the language, it's the language plus the various rules about how calendars work, how dates work, how time works, etc., etc., etc. So in .NET, we have access to the culture info class, which contains information about any currently supported culture in Windows system, which is quite about every single culture in the world. Maybe some tribes in Amazonia do not have a supported culture in Windows, but I don't think it is a big problem. But for major of the world, for practically every official country, there is at least one available culture. So let's take a look at how we can use culture info to help us manage, for example, translations of typical things such as dates or times or actually like formats, etc. So what I'm going to do here is I'm going to create a new culture demo. So here what I'm going to do is create a variable which I'm going to call culture, and I'm going to use MS Corelib again, and here I'm going to go to system.globalization namespace and then culture info. So this culture info now contains plenty of information that I can require for manage anything localizable, like starting with the calendar. Windows supports many different types of calendars, or like the number formatting or date formatting, or I could use cached cultures in Windows to make performance faster. I could construct cultures on the fly. It doesn't require any kind of installation on either server or the client. So here what I'm going to do is I'm going to actually construct a culture. So since Luke has said that most of you come from Netherlands, who is from Netherlands? Okay, so I'm going to use the Dutch in Netherlands. This is an identifier for Dutch language. So first we have language name in cultures, and then we have country name. So these are identifiers for culture. So here what I've done is basically I have created a culture info which is aware of all of the specifics of the Dutch language in Netherlands. So typical things which I might want to use is to actually translate names of months. So let me declare another DT variable, which is going to be of datetime type. So here I will select system.datetime. And then I'm going to say that I want to set DT is current date time. And imagine that I just want to show this in the current, in a specific format for Dutch culture. So how do I do that? I actually call DT and then method toString. Every class in .NET has a method toString, and every toString method can also be made to localizable, which means like when you are creating your own classes, you could make them localizable easily because it's a facility built into .NET. I will explain later how exactly. And here we can just say toString, which would print the date and time just in its raw format according to the current display settings. But I could also specify the format provider. Format provider is an interface which says how to format a date or time. So this format provider is an interface that a class must implement. And luckily, this culture info class implements the format provider interface, which allows us to actually use culture information with any toString method for any of the classes to translate anything or actually to localize anything, to show numbers in a local or currency in a local way, or like any date, time, numbers, and similar information. So here what I'm going to do is I'm going to specify, so dt.toString, and then I can simply say culture. So I'm formatting it according to Dutch in Netherlands specific formatting requirements. And I run that, and this is this correct? It should be. Okay. Let's try different things. So here another overload of the toString method is to use the format. So here I can put DDDD, which is, actually I'm not quite sure if this is the long, if the DDD is the correct one. But it's not even important thing that I know how to specify long formatting parameters for dates, because it's already a part of the culture. So I can say culture.datetime format, and then I specify long date pattern. Okay, and that's it. So I specify that, and I run this, and now it will tell me something. I can't read that, but it's correctly translated into Dutch. So as simple as that, you can, when, for example, sending invoices to Netherlands or to Belgium or to Denmark or Japan for that matter. So let me use Japanese in Japan, or vice versa. I think this is correct. And now we have it in Japanese. So since .NET is Unicode and since NAV is Unicode, it's simple to use this directly in all of your code. So that was culture info, that was datetime format info, and similar to that is number format info. I'm not going to specify that in the number, or actually talk more about that. In number format info, what you have is information about formatting numbers, formatting decimals, formatting thousands, formatting currency, etc., etc. Okay. Not very common, but useful to know is that sometimes we do calculations in which exceed the capabilities of CAL. Who has ever had to do some kind of calculation, let's say trigonometrical calculations in NAV? Okay, I didn't expect too many people to raise their hands. But if you did need something like that, you could have developed your own library, like a code unit of functions, but they would be slow because like CAL executing trigonometrical calculations is not the best thing in the world. We have one class which is called system.math, which allows us to call many different mathematical functions, really many different mathematical functions. They go way beyond what CAL can do. I'm not going to go deep into that. I'm just making you aware of this class, which can really handle that easily. So you have seen how to declare classes. You can find this one in system assembly. And then another one that I'm going to hint into is big integer. It's extremely unlikely that you would have ever had to exceed the maximum capacity of the big int data type. Did anybody ever exceed that? Okay, I didn't really expect to see that many hands, but it means that people did encounter this problem. So big integer is 64-bit integer. It can handle quite a lot. I think it can handle up to 13 or 14 digits. For situations when you need more, we have system.numerics.biginteger class, which can handle unlimited number of digits. So I think I have a prepared demo for that just because it's cool to see, not because of anything else. So here I have this, and then I will again collapse all, and I have this big int demo. So here I have maximum integer. This is maximum 32-bit integer, and then I multiply it 100 times. So I 100 times multiply it by itself. So basically I raise it on the square. So it's pretty big number, trust me. So what I'm going to do is I'm going to run this big int demo, and then run this class. It's kind of very fast, and it's a pretty big number. So not that you would ever have to use that big numbers, but if you need to make calculations with really large numbers, you can use the system.numerics.bigInteger type. There is just one more type in this system.numerics namespace. It's called complex. So just in case you ever had to do complex mathematics in NAV, now you have the system.numerics.complex. I'm not going to do any complex mathematics. That's just because I don't understand it anymore. Okay, let's take a look at one more class, which is system.convert. We can use this class to convert, okay, I will dare saying anything to anything. Okay, it's evaluate on steroids. Who has ever used evaluate in CAL? Okay, don't need to really put hands up. So what does evaluate do? It takes a string and converts it to a number or to a date or to something like that. So it is kind of useful, but it has very limited functionality because it can only take a string as an input. You cannot, for example, convert date into an integer, which could be interesting, or integer into date, or integer into time span, or something like that. You can try assigning directly, but it doesn't always work. Sometimes compiler complains, sometimes runtime complains. So system.convert can convert practically all of simple data types to all of other simple data types, at least as long as this conversion is actually meaningful. If it's not meaningful, then probably there is no method to convert. But you can convert really between many, many, many different simple data types. And you also have a possibility to at least try to convert a class into another class. So this is a very funny one. So you can actually try converting classes. It will try to match the properties and then try to retain as much as possible. So it's a useful class to know. I don't have really like a cool demo about that. Let me move to the last part of today's presentation. We have half an hour left. So let's talk about managing data. The first namespace that I will introduce here is system.io. So who has ever had to handle files? Let me see. Okay, who has ever had to handle streams? Okay. And who has ever had to handle things like arrays or similar collections of data? Yes, okay. So a lot of you. So I think this will be relevant then. System.io.file is the first class that I will introduce today for you. It is helping you manage files. I mean, it kind of is obvious. So handling files in NAV allows us to do what? What can we do in NAV with CL? We can create, right? We can check if the file exists. We can delete the file. What else can we do with the file? Read the file. Okay, of course. It would be kind of strange if we couldn't at least read the file. So that kind of sums it up. In .NET, of course, I mean, the files are just files. But still, system.io.file allows us to handle many different situations with files, and such as handling typical operations with files. So what are most typical operations we do with files? We read and write. So that's what we do with files. So often, out of NAV, we export data, and often we import data. So for situations when XML ports cannot handle the files, we typically write our file handling procedures ourselves. So let's take a look at system.io.file and how that one can help us. So here I have a folder, which is, no, not that one, this one. So it's local disk C and then /temp. So here I want to create a file to just write, let's say, list of customers with just customer names, for example. So I will start a new code unit. I will declare customer record and then file. So here I go to system.io. Actually, it's here, system.io.file. So how many lines of code do we have to write in CL to write to a file? At least 3, right? We need to at least open the file, then write data, and then close. So sometimes when handling files, it can be like a lot of code. You have to think like, how do I do this? Is this correct? You have to test. So here we have a very simple method. So I will do if customer.findSet, then repeat until cust.next is 0, and then I will do simply file, and then append all text. So what I specify here is the path, so c temp and then customers.txt, and then something like customer.number, and then customer, actually I will put plus this and then plus customer.name. Okay, and then I run this. So I get my file without having to write anything else. So without having to create a file, to close a file, we have a simple function that whenever you need to add something to the end of the file, you simply call this append all text function. Now it doesn't look quite nice, right? Because I don't have line breaks. I just have a bunch of text. So again, how do you put a line space into a text file? What's the character sequence for that? 1013, okay. But it might be something else depending on like the operating system, etc., etc. So in Windows, it is always 1013. So to not having to think about how to put 1013, how do we put 1013 into a string? We have to create two characters, and then 10 and 13, and then concatenate them, etc. So without having to worry about that, again, .NET has a simple class which handles that and many other situations which relate to how environment handles certain things. So I'm just going to declare environment variable, which is again mscorelib, and it's system.environment. And here I'm going to just append environment.newline. Okay, and that's it. So I don't have to worry what it is. Is it correct sequence? Is it going to handle like specifics if the operating system works differently or is configured to work differently? I can just use that one. And then let me delete this and just run the same piece of code again. So the file should be here, and now I have all of that in a specific line. Okay, so before I go to the next class, I'm just going to actually try this. Temp, subfolder, another subfolder, and yet another subfolder. Okay? And try to run that. Will it work? No. Why not? Because I don't have that structure. So if I try to run that, I see that this path does not exist. So has anybody ever handled situations that you had to verify if a path exists and if it does not exist to construct the whole path? Okay, quite some of you. Was it like just straightforward work? For most of you, yes, but still let me make it simpler. Okay, so there is another class which we can use here, which is called directory. So system.io.directory. So here I will just use the directory class, and I'm just going to use one more variable which I will call just path.net. Sorry, it's text. Text. And I will just take this into this path. Okay, so here what I can do is basically just go and call this directory dot create directory and reference a path. So I will use path here, and let me take this customer.txt out. And then let me just use path plus customer.txt, okay? So imagine that this is an export situation when you are exporting a bank payment file, and then this is the folder which comes from your configuration, like you have, let's say, sales config, or financial management config, or whichever config, a setup table which contains the path where files should be exported. So if I call this, it will fail, because I will still not have this path, and I will not have this path because I'm not sure if this subfolder has this backslash in the end or does not have this backslash in the end, right? So this is a typical situation that whenever exporting files, I'm pretty sure that majority of people who have written code that does that have done some logic that says if last character is backslash, then just append the file name. If last character is not backslash, then append backslash and the file name. Who has written code like that? Okay, good. So let me introduce one more class here which can handle situations such as that. So we have P, which is again .NET, and it's system.io.path. This one handles many different path situations. So here what I'm going to do is simply create directory, and then I'm going to say that path is P dot, I'm not quite sure about the name, combine, and then actually it has to be lowercase o, not uppercase o, so path and then customer.txt. And then this one does the logic. So a typical wheel that we tend to reinvent. Okay, so let me run this. So roll-tailed client does not complain. And here I have subfolder and another subfolder and yet another subfolder and then this one with properly appended backslash in the file name. So typical situations where we tend to spend unnecessary time reinventing wheels which are already there. And somebody might have asked, how come I didn't have to instantiate any of those? File, directory, path, whichever I have called. That's because for some objects or some methods in .NET we have a concept of static. So when we work with objects, we normally have to instantiate them. Like string builder, then we instantiate a string builder. And then we work with this instance of string builder. While for other objects, we do not need to instantiate them, we just use them. So there is a big difference between how those two really run on the system level, where the information is kept about them. But there is also logical information, a logical decision process in when people actually create static classes and when they create dynamic classes. So static classes and static methods are those classes and methods that do not require an instance. So you can just call them directly on a class name. So here, file and directory and path, they are all static classes. There is no need to construct them, to instantiate them. There is very simple rule of thumb in the whole of .NET, at least those parts of .NET which is covered by Microsoft, when something is static and when something is not static. So first, having static stuff is not good, because then it is static. It allocates memory and it stays alive. It stays in memory for the duration of the application. Actually, we call it application domain in .NET. It's different than the application. There can be multiple application domains, but don't worry about that. One application domain in NAV is not the session of the client, it's actually the lifetime of NST service. So only when you stop the NST, application domain dies, together with all static classes and everything that was static dies. So even if you have one connection, like one session of NAV calling something static, that static remains in that memory forever. So that's one drawback of having something being static. So why do we need static methods? We typically need them when the method itself does not need any kind of context to handle. Like for example, let's take a look back at the append method of the string builder class. When we called append, we need to know to what do we need to append. So we have to have some context, some string builder, and then we append to that, and then we append to that, and to that, and to that. Okay? With file, if we want to append text and specify the file name, because file already exists as an object, no need to keep it as a separate entity in memory, we specify which file to append and what text to append, and it was static. It didn't require anything before starting appending, and after completing the appending of text, it doesn't need to keep anything in memory. Or create directory, for example. It doesn't require any context. You just say, create this directory. And the system has all the information that it needs, and after it completes, there is nothing left to check for you, like the directory is there. So this is static methods and static objects. I'm not sure, tomorrow I might be showing something about static objects, It depends on last-minute decisions I make about like what is the coolest and what is less cool to show tomorrow at the black belt session. But I did show a little bit tips and tricks about static objects last year, so you can download from Ibuso to see like how to use static objects to do funky things in NAV. So I've shown the directory and I've shown the path. Here comes one more interesting class. So this one again solves a problem when you need to respond to a situation in file system. So who has ever had to import files at the moment when they appeared? Okay, good. So how did you do that? Can I guess? You had an a NAS running, which was running a loop, which was looking at the folder, making sure that the file which matches a certain pattern appears, right? Or something similar. Okay. So in .NET we have file system watcher class, which really raises events when a file appears. So you don't need to watch anything, you don't need to spend time on anything. You simply have this file system watcher, and then when a file appears, you get notified. You just get an event, a trigger if you want. So let me show an example. I will first show the example, how it works. So here I have a page that I've developed yesterday with the class. Actually, it's 50,001. It's called File System Watcher Demo. And here, what I have is a page, which is a temporary page over the file virtual table. So it is watching this c.temp folder. So when a new file appears, then the file will appear in this page. And when a new file appears, like this, and then 4 more, here I get notified about all of these. I could, of course, do it a couple of more times. I will not overdo. So this is that, and then I delete the file, and then it's aware of, oops, that's a special effect. Then I refresh, and then it's gone. Or I could delete all of them, and then all of them would be gone. So let me leave this customers for whatever reason. Okay, it was there already. So it was there. It was created before I had a chance to respond. So it works. So let me show how it actually works. First, let me explain the concept of events. There is nothing funky about events. Events in .NET are very, very similar to event triggers in NAV, and we are pretty familiar with event triggers. We have been responding to onInsert, onModify, onDelete, etc. for the duration of our professional CAL career. So we know what events do. When working with events, we can respond to all of the events that a class publishes. So let's take a look at what we need to do before we can respond to events. So here we have this file system watcher class. This file system watcher class is exposing certain events. Just by declaring that object, I'm still not responding to events. So to respond to events in .NET, in CAL, you actually have to set the with events property. And when you set the with events property, what happens is that you get several triggers in the end. All of them start with the name of the variable, followed by double colon, and then by event name. And then here you can put the code which responds to events. So whoever has done any, can you just see like how many of you have done .NET programming in C# responding to events? Okay, yes. So you know how event looks there. It pretty much looks the same here. So most of the events in .NET have one event pattern that they follow. They at least have the sender variable, which is the object that raises the event, and it's of type system.object. We'll talk about that quickly. It actually shows up as a variant. I will also explain why. And then we have event arguments, which is a class which contains the data about the event. In this case, it is the system.io.filesystem event arguments, which tells me like which path, which file, etc., about the file system change. And then by simply exposing this event, I can respond to, or actually by registering this class with events, I can respond to events as they are being raised. There are a couple of considerations with events. First, events can be client-side and can be server-side. So with each .NET variable, at least global .NET variable, we can specify that variable runs on the client. By default, it does not, but we can make it run on client. If you're running events on client, remember, you can do that only within a page object, not on any other object type. That's just because the page stays alive on the client end, while anything else that executes after it completes execution, it ends. Like when you call post from a page, the code unit that has posted it, it's gone. So it goes out of scope and it dies. So this is not like that with the page itself. So the page can stay and keep responding to events. And there is another thing that you must think of when dealing with events is the synchronous and asynchronous events. So I will talk about synchronous and asynchronous concepts tomorrow in the black belt class, so I will not go into details here. But just remember one thing. When events are synchronous, it means like you have an object which sends an event, the object waits for event handler to complete, and then the object continues executing. With asynchronous events, object notifies the listeners, if there are any, and object goes on. It doesn't wait for any response from the listener, which means that event is not raised on the same running thread as the object itself. It raises another thread to handle that event. And NAV cannot handle that situation. NAV is a single-threaded application. It does not support multiple threads, at least within the context of a single user session. So one session equals one running thread. And if you have asynchronous events, you can easily crash NAV, depending on what you do. I will handle that tomorrow. I will explain how to respond properly to those situations. Here we have another concept, which is enumerations. These are more or less equal to options in NAV with some differences. So enumerations are simply collections of named constants. So such as, for example, document type in table 36, you have named constants like quote, which is 0, then order, which is 1, etc., etc. So these are options in CAL or NAV, and similar concept in .NET is enumerations. But there are some differences. In CAL, they are always integer, and it means like they are always int32, which means 4-byte integers. In .NET, they can be of any numeric type, which can make troubles when passing them between .NET and CAL. Another difference is that in CAL, all of the options are always zero-based, which means the first option is 0, the second is 1, etc., etc. In .NET, if you don't do anything funky, they are also behaving like that, but developers can assign specific values. Like they can say 0 is quote, 1 is order, 15 is invoice, and then keep the rest blank for whatever reason. There are plenty of interesting reasons. And then finally, in NAV, it is always 1 plus 1 plus 1. In in .NET, as I've said, it can be any value. You can assign any explicit value to any of the options, even negative ones. So it's completely up to you. And then just a little bit about how enumerations are supported in CAL. They're not supported at all, or not really supported in 2009. In 2013, we have pretty good support for enumerations. We can see enumerations. So let me show how enumerations show up. So here in this object, I have the file system, notify filter, which is an enumeration. So if you have a variable or a type which is enumeration, then you have enumerators. And then you have options here. There are plenty of enumerators that you typically pass on to a class to modify how it behaves. So they serve the same purpose as in NAV. For example, here, what I did is I used enumerators to specify bitwise combinations of values of an enumerator. That's something this is the last difference here. This is something that .NET can handle natively that NAV cannot handle at all. These are practically option variables, which can be all of the option values at the same time, or a combination of the option values at the same time. This is something very common in C-based languages such as C#, but very strange to NAV. So, and again, this is not supported in NAV, and a way to support that in NAV is to use the convert class. So you simply convert an option into an integer, and then you do the addition operation on them. And that's how you combine them using bitwise OR. That is pretty common in CAL. Let me quickly move on. I will not show that one. I will post all of the examples on my blog so you can follow this. So who has ever had to write to event log? Okay, I assume it was not too easy. It was pretty complicated because you had to register a source first, and then you had to call that source and do funky things. In .NET, again, you can just write a single line of code if you want to write to event log, nothing else. Declare event log variable, and then just call write entry function and specify the name of the source. If you are writing for NAV, you just specify Microsoft Dynamics NAV server, and then it writes to event log without anything to worry about. So I will skip that demo, and then I will talk a little bit about type information. .NET is pretty strongly typed language. NAV is not a strongly is still a strongly typed language, but integration between them is not quite the way it would have to be. Strongly typed means that every variable carries a data type, and it is strong. It means like if you have an integer variable, you cannot assign a string to it, or vice versa. So if you want to like put integer into a string, you would call format. If you want to put string into an integer, you would call evaluate. But if you want to put datetime into an integer, you cannot do that because they are two completely incompatible types. .NET is also very strongly typed. So in .NET, every variable is of specific type. We have one interesting type in .NET, which is called system.type, which allows us to gain insight into what a type can do. So there are plenty of things that a type itself can do. And this is a concept that I will elaborate on tomorrow. I'm going to show some interesting tricks about how to use system.type to make things possible which normally wouldn't be possible with pure CAL.NET integration just because of the limitations of the interoperability. Remember that we have two functions with types. One is get.NET type, which tells you what is the type of a variable. And again, I will show some tricks how to use it tomorrow. And then can-load type, which is a very interesting one. Can-load type is solving the problem that most of you have had who have used automation variables. Who has ever used an automation variable, okay, and then had problems when deploying it, like automation server wasn't available, and then you wanted to compile objects and it was complaining. So, for example, you were upgrading and then code unit 412 didn't compile because you didn't have the developer license for Visual Studio, and similar. So these are typical problems with automation because you didn't have a way to work around automation issues. So here what we have is can-load type. So if you do not have .NET assembly present on the system, you can still compile. You can still develop. Compiler will not complain. But what will happen is that runtime will, of course, complain if the type cannot be loaded. But then you can call the can-load type function to verify if the type is available. If it's not, you just get false, and then you can gracefully handle the situation without a system crash or like an ugly error message that users will just get scared and not know what to do. A couple of more concepts. So a little bit about arrays and collections. Arrays in NAV are very similar to arrays in .NET. They are all fixed in size. They are allocated at the moment of declaration, and they cannot change the size. They are of a strong type. So very similar between NAV and .NET. We have what is the problem with the arrays in the interop is that arrays in NAV are not compatible with arrays in .NET. So if we have to pass an array of something into .NET function, we cannot just use NAV arrays. So we have to declare them as arrays in CAL. So we have system.array class for that. Again, there are a couple of demos that I'm going to upload to my blog. I will not show array itself because it's not too interesting. What is interesting is collections. So collections are something that we are not familiar with in CAL. Collections are similar to arrays in the way that they contain a range of values of the same type. However, that range is flexible. It's a runtime defined. So you can add, you can delete from it, you can resize, etc., etc. And then you can do some other functions such as sorting the collections, etc. So what I'm going to show here is a couple of interesting collections. I will skip system.array, and I will also skip this concept. This is kind of advanced. I wasn't quite sure whether to include it. I said if there is time, I will talk about that. If not, I will skip that. And I will skip this one as well. This is just one type which rules them all. It is mother of all types. Again, tomorrow I will talk a lot about system.object and how it behaves. And then I just want to jump to one collection that I want you to go home with, which is the hash table. So hash table is basically a collection of keys and values. So situations such as when you need to do some kind of a lookup. And I guarantee most of you have done lookups, at least like looking up a customer in a database to do something on it. So how do you do a lookup based on key? You use the get method, right? So use a get method to look it up. And how often did you want to cache something, like have temporary table, which contains information, and you did lookups on temporary tables? Okay. And it was really efficient. NAV is pretty good at handling temporary data. It's pretty good at handling it in memory. But there is an even more efficient way of handling those lookups. So what I've done here is I have prepared a demo which uses the hash table. So here I have the hash table demo. This hash table demo compares the speed of using a temporary table to look up customer information and using the hash table to look up customer information. So what I have here is an iteration of 1,000 loops where I read customer from customer table and stuff it up in the customer temporary variable. And then I do the same, I just put it into the hash table. And then I actually do time measurement. So here what I do is I do 100,000 lookups first from the customer table, temporary table, and then 100,000 lookups from the hash table. And I'm measuring just this lookup time. I'm not measuring any other overhead that I have. And here I see the difference between how much time it took to look up 100,000 objects from temporary table in NAV and compare it to how much time it took in .NET. So here I'm just going to call hash table demo, and I will run this. I apologize for 2 minutes. I will steal 2 more. So I will run that. Did I run it? I think yes. So it says that it has spent 2,371 milliseconds for 100,000 lookups, and here I've spent 400 milliseconds for 100,000 lookups. So it's pretty fast. So if you need to do a lot of lookups, you need to store something temporarily somewhere and then look up extensively on that, you can use hash table instead. It's pretty straightforward how to use it, and it's pretty efficient. And again, it can handle 2 gigabytes of data, which I'm not quite sure that a temporary table in NAV could. So if you have a very large lookup, it would still be very efficient. So let's just quickly move on. I will skip lists and generics altogether. Tomorrow I will really take them apart and discuss a lot about how to manage generics. There are also a little bit of the advanced concept that I kept just in case I need to. I get enough time. I didn't. I apologize for that. One more type that I'm going to talk, and here I will close, is system.io.stream. So who has done streaming? Like exporting from XML ports, putting stuff into blobs, managing streams with files. I imagine most of you have. So streams are powerful, they are flexible. There is nothing particularly wrong with streams in CAL. There is nothing to improve on streams in CAL. But still there are situations which you probably had to handle and you couldn't. Some limitations that, like, you could only handle blob streams or file streams. We have pretty nice integration between .NET streams, which are powerful, really way more powerful than streams in NAV, and NAV streams. So we have system.io.stream type in .NET, which fully and directly maps into the stream object, inputs in-stream and out-stream object in NAV, which means for whichever purpose you would use in-stream or out-stream, you could actually use .NET streams and then either manipulate them programmatically or do very interesting, funny things. So here I have another demo, which is stream demo. Actually, not that one, but picture demo, where I have very short piece of code. First one, I use another class, which I will not explain here. It simply downloads a picture from internet, or it can download anything from internet, like a web page, like an XML document, whatever, like a file. And then it gives you the binary results. Sorry, this is the URI. This is downloading here. Web client.download data. This is downloading and returning the binary, the byte array, basically the binary information for whichever resource you downloaded. And then I have constructed a memory stream from it. Memory stream is a descendant of system.io.stream. So I have a memory stream which contains the picture that I downloaded from the internet, and then I get an item. I create an outstream for writing into this picture column of the item table, and then I simply copy this memory stream into this outstream and modify the item. So let me call this demo. So it's picture demo. I will not run it. I will first verify that my item 1000 does not have a picture. So no picture here. Let me take this picture and see what it is. So I will load this picture. That's a bicycle picture. Not particularly nice, but serves the purpose. I run that, and with everything being okay, I can verify that the bicycle picture is in there. So it's a very nice way of handling streams. They're really very, very powerful. I can't even start explaining how powerful they are. Maybe I could have a session just about streams next year if I can manage to convince Luke. Okay, so this was system.io.stream. So here, with this I end. I hope there was at least one class that was useful and that said, okay, it was worth coming to this beginner's presentation. I invite you tomorrow to join me for the black belt presentation, where I'm going to discuss most of the limitations of .NET Interop and how to overcome them in practical situations. Are there any questions? Whoever dares to ask something, or whoever cares to ask something, I have a shirt, so it means I can accommodate up to 5, those who care or dare. So let's see if we can help you with something. Okay, yeah. Go.
Looks like the inability of the compiler to detect cases where the object has not been initialized and we call a non-static method is like creating a time bomb in the system. Because at runtime, we may have runtime errors. So is there anything on that front? Is the compiler going to change to detect that, or do you have any workaround?
So actually I didn't, the question was that we might have a time bomb in the system because of compiler ignoring whether a method is static or not, and then we can encounter runtime errors because the compiler did not detect properly if something is static or dynamic. Actually we don't. Actually compiler detects if something is static. And actually, yes, I apologize. That's for C# it will detect. Yes, I understand the question. I apologize. Yes, in NAV, in CAL, yes, we do have a time bomb, but then we can do something like check is null. There is a function which is called is null. So it's CAL function, and then you can see if the object is instantiated. So before using an object, a good practice would be to say if is null, then, and then you do something. When you write your own functions, you should remember to call, to actually instantiate objects. When receiving objects as parameters, you should call is null before making any functionality. But yes, there is a time bomb sitting, but there is a workaround that. So CAL compiler, unfortunately, is not as smart as C# compiler. There are various reasons. It's intentionally not trying to be too smart. So I do not believe that they will change the CAL compiler to actually be able to detect if you are calling a static method or not, just because of the very simple reason that you first have to declare a variable of a type before you can use it. So I think you deserve a shirt. It was a pretty good question. So I had another question here, then I'm going back to you. Okay?
At the very beginning you said that everything runs in .NET, not in Cal code. I thought Cal code compiled into C#.
So what happens when you save an object and compile it is that the object is translated to C# first. So you get C# translation of the CAL code, really one-on-one. And then when you run the object, you just have the just-in-time compilation. So what NAV does, it invokes the just-in-time compiler, it compiles the class and loads the assembly into memory and uses it for memory. So basically, whatever happens is it runs on a pre-built C# code. So that's what happens. But it's not CAL code which is executing, it's really compiled C# code which is executing. Yeah. Okay, so a shirt for you. Yeah. I had a question over there. Yes?
Yeah, how should we or how can we handle exceptions from .NET? I mean, if I call assembly and there's an error, how can I handle it? Can I just write a try catch in CAL?
So this is, if I may say, a darn good question. So I will give you a shirt before even answering. So unfortunately, we don't have easy ways of handling exceptions. So .NET is full of exceptions. Yesterday, I had a question from the class, like in NAV, if you want to delete a file and then you call erase, it will give you true or false. And in .NET, when you try to delete a file, and if it fails, you get an error. So how do you handle that? Why don't you have like booleans in .NET? The answer is, in .NET, let me just move a little bit down so that everybody can see me. In .NET, everything is catchable. So you have try-catch blocks. You can put try-catch, and then something that can fail, it goes into try block, and then if it fails, you get catch block to handle the error. In NAV, you don't. So there is no easy way. So there are two workarounds. One is ugly, and another is bad. So there is no good workaround. The ugly workaround is to write a code unit and then call it with code unit run. But you could quickly run out of code units if you do it for every single situation that you handle. You could make it uglier by having one code unit handling all of your situations with just one on run and then setting some flags like call this function, call that function. You would pretty quickly encounter into a problem with that approach. I do not recommend that. Another approach, which is bad, but not as ugly as the first one, is simply write your own .NET class. Wrap a function in try-catch block and then call that function and have that function return true or false. And some .NET object, which might be a container for all the results that you want to handle. So unfortunately, nothing else. And I don't think something is on the horizon for Microsoft, because I think it would change the way how NAV works. It's not even possible to use any funky tricks to make it happen. I will discuss that situation tomorrow, so I wanted to discuss the try-catch situation and problems around that and the reasons why you cannot handle any errors directly in NAV. So that's it. Yeah, another question.
In the MS Core Lib, you have several versions, the 64-bit, the 32-bit.
Mm-hmm.
The client is 32-bit, the server
Yep.
is 64-bit. Do we have to handle that situation? Select the...
Yeah, so this is also a good question, so it deserves a shirt. There is one more, so I don't know who is going to have good questions. So far, all have been good. So not just MS Core Lib, there are plenty of different libraries which have versions like 64-bit, 32-bit, etc. So when declaring variables, first you have to specify where it runs. Does it run on the client or on the server? So for MS Core Lib, at least if you make a mistake, the NAV will select the correct one. And it will do so for all of the system-based assemblies that are provided by Microsoft. So if you specify a 32-bit version, it will try to load 64-bit, and vice versa. If you specify 64-bit on the client, it will try to instantiate a 32-bit. For your own, you would have to either provide them and put them in the global assembly cache, or you would have a problem. So that's it does follow the version that you specify. So if you specify version 2.0, it will really load version 2.0, not version 4.0. At least in 2013. In 2009 R2, it wasn't like that. You couldn't specify incorrect versions. You have to specify exactly the version that was supported, and 4.0 wasn't supported. But in 2013, it's a little bit smarter. Okay. So something else? One more question? Okay. Do I give you a shirt?
You have told that the static classes are server-wide, even on multi-tenancy?
Yes. Yes. So this was a surprise question, so I give you the shirt. So actually here I'm giving the answer, but I'm actually just like educated guessing it. I don't have the time to actually prove that right now, but I'm like 99.9999% sure that what happens with multi-tenancy is you still have one service tier running. There is no overhead for other tenants. So it's one application domain, really, for all of the tenants, because Microsoft did not want to add any. So what happens is that when you have a static class, it's very dangerous in multi-tenancy scenario, because it's static. It's basically one context for all of the sessions for all of the tenants. Pretty dangerous. So that's why I said, like last year, I said, don't do this at home with static classes. Be careful with static classes. Yeah. Another question over there. Yep.
It's possible to create huge classes,
Mm-hmm.
maybe to put in a lot of logic in them. Is there somewhere a possibility that we don't have to use .NET inside NAV, or can we use everything what we can imagine? So
Okay, I will try to rephrase, to simplify the question. You help me if I didn't catch it. So, can we use whatever we can imagine?
That's like I think about this.
Yeah.
I'm looking about if we can use everything out of .NET, if we can
Yes. Okay. So.
own classes and
So.
namespaces, then
Yeah.
we can do everything outside NAV standard source.
Yes, that's so. The question is like, can we really access all of .NET? And like, should we do that? Should we put? And let me expand a little bit, like the unsaid part of the question. Should we program in .NET rather than in NAV? Where should we put our business logic? Okay, there is no simple answer to that because it's more of theoretical question and theoretical answer. But tomorrow I will handle one specific situation where I will argue for a method where you would put business logic outside CAL. So anything like data retrieval related you could keep in NAV. Everything that goes beyond that, I will argue to put it outside. And I will give you a very convincing reason for that. So yes, you can use all of .NET, all of global assembly cache, all of the assemblies that you can gain access to, you can use them. As long as the assembly doesn't do something like sealing the classes or like making them internal or something like that, then you might have troubles depending on what the assembly does. But without any special precautions being made by the developer, if you gain access to the assembly, you can use it.
So it's possible, but not always a good idea.
It depends. It depends on the situation. So I would say that as long as you can call something from .NET and it accomplishes the task, do it by all means. Should you write your own assemblies to handle business logic? It really depends on the situation. Tomorrow I will give an argument for doing that.